Okay, welcome to class, students. Today, we'll be looking at a very important topic titled Toxicology in Occupation. Toxicology in Occupation. What does toxicology means? Toxicology is a branch of pharmacology that deals with nature, effects, detection, and treatment of poisons and poisoning. So it's a branch of pharmacology that deals with the nature, the effect, detection, and treatment of poisons and poisoning. Health toxicology is the study of harmful interaction between chemical substances and biological systems. In contemporary industrial and environmental contexts, humans and other organisms experience unprecedented exposure to an expansive spectrum of chemical compounds. This chemical diversity encompasses simple inorganic elements, metallic compounds, and intricate organic molecular structures, all possessing inherent toxic potential under specific exposure conditions. The modern industrial landscape utilizes thousands of distinct chemical substances across various manufacturing and processing operations. This chemical proliferation creates inherent exposure risks for workers engaged in this industrial environment. While advanced industrial facilities often implement closed system technology to minimize direct worker contact with hazardous substances, complete exposure prevention remains challenging in many settings. So we want to look at the routes or pattern of entry for toxic chemicals. Toxic chemical can enter or can get access to us through inhalation pathway, skin absorption, injection and injection. Inhalation pathway, skin absorption, injection and injection. So let's look at one by one the pathway or the route at which these toxic chemicals gain access to us. The inhalation pathway. Respiratory exposure represents the predominant route for industrial chemical exposure. Any substance represents in aerosolized vapor or particulate form becomes potentially inhalable. Let me take that again. Respiratory respiratory exposure represents the predominant route for industrial chemical exposure. Any substance present in this aerosolized vapor or particulate form becomes potentially inhalable. This quantitative absorption of toxic compounds via respiratory structure depends on multiple variables such as ambient air concentration of the substance, temporal duration of exposure, pulmonary ventilation volumes, which increase proportionately with physical extraction and metabolic demand. We have skin absorption is another pathway. Continuous Cutaneous absorption constitutes a significant entry route for select chemical agents. When substance contact skin surface, four po outcomes may occur. This cutaneous absorption. We have the barrier function preservation. This integumentary system successfully prevents compound penetration. They will have the local tissue reaction. This substance interacts directly with skin structure, producing irritation or tissue destruction. We have the sensitization response. The compound induces immunological sensitization mechanism in dermal tissue, We also have transdermal penetration. The substance traverses skin layers to access underlying vascular structures and subsequently enters systemic circulation. Injection is another pathway or route for entry of toxic chemicals. While deliberate chemical injection rarely occurs in industrial settings, accidental injection represent an ongoing risk factor. Workers may inadvertently ingest toxic substance through consumption of food or beverages in contaminated work environment. Transfer of chemicals residues from contaminated hands to food items during meals or breaks, oral contact with contaminated smoking materials or other objects placed in the mouth. Injection though relatively uncommon in industrial contexts, direct injection of substance may occur under specific substance. Injection exposure can deliver compounds directly into the bloodstream, that is intravascular, enter the peritoneal cavity, that is intraperitoneal, enter the pleural space, that is intrapleural, dermal tissue, that is intradermal, muscular tissue, intramuscular, any anatomical location accessible to the needle penetration or high pressure fluid injection. Dose response relationship assessment. Acute exposure. Acute exposure involve chemical contact occurring within a condensed time frame, typically defined as 24 hours or less. This short duration exposure often involve higher concentration and may produce rapid onset toxicological effect. Chronic exposure. Chronic exposure encompasses prolonged chemical contact ex across ex periods, weeks, months, years. This sustained exposure patterns frequently involve lower concentration but may cumulatively biological effect through persistent contact. This one means why it's about its result, its effect can be, it does not, chemical does not show immediately, it as a result, the effect is as a result of bioaccumulation. This sustained exposure patterns frequently involve lower concentration but produce a cumulative biological effect through persistent contact. That means there is, it's bioaccumulated, it is being accumulated till when it begins to, till when its effect is being seen. The resulting toxicological impact depends on a complex interrelationship between exposure magnitude and the intrinsic toxicological properties of the specific chemical agent. What is dose response? Dose response is a relationship between exposure and health effects that can be established by measuring the response relative to an increasing dose. This relationship is important in determining the toxicity of a particular substance. It relies on the concept that a dose or a time of exposure to a chemical, drug or toxic substance will cause an effect on the exposed organism. Usually, the larger or more intense the dose, the greater the response or the effect. This is the meaning behind the statement "the dose makes the poison." Health effect of toxic chemicals. We have the temporal classification. Temporal classification is the acute poison and the chronic poison. Acute poisoning manifests following rapid substance absorption where exposure occurs suddenly and in significant intensity. This event typically involve single high concentration exposure exemplified by carbon monoxide or cyanide poisoning incident. Chronic poisoning. Chronic poisoning develop through ex ten ded or recurrent exposure spanning days, months, years. Symptomatic manifestation may emerge gradually without immediate clinical evidence. Classic examples include lead or mercury accumulation and persistent pesticide exposure effects. We have the anatomical classification, that is the local effect. Local effect occur directly at the exposure contact site without requiring systematic or systemic absorption. Po ten tial target tissue include the skin, the mucous membrane, the respiratory epithelium, the gastrointestinal surfaces and ocular structure. Strong acid and alkalis exemplify agents producing primarily local effect through direct chemical interaction with contact tissue. Systematic effect. Systematic effect manifest at anatomical location distant from the initial exposure site, necessarily involving absorption and distribution via circulatory system. This pattern is illustrated by inhaled toxicants subsequently affecting the hepatic function. Arsenic exemplifies a systematic or a systemic toxicant with multi-organ effects across hematological, neurological, hepatic, renal and dermatological systems. Types of interaction: we have the addictive interaction, the antagonistic interaction, the potentiating interaction and the synergistic interactions. Factors influencing toxicity: the toxic po ten tial of chemical hazard exhibits significant variability based on multiple determinants affecting both the substance and the exposed individual. We have the chemical properties, the intrinsic molecular structure and biochemical reactivity. We have the dose time relationship, quantity administered and temporal exposure pattern, the exposure route, pathway through which the substance enter the biological system. Species variation: toxicological difference between taxonomic group. Of the age-related susceptibility, life stage dependent response patterns, sex-based differences, gender-specific metabolic and psychological variation. We also have the absorption efficiency, the rate and extent of uptake into biological system. We have the metabolic processing, we have the tissue distribution, the excretion mechanism, that is elimination pathway and clearance rate, and chemical interaction, that is presence of other substances affecting toxicokinetics or toxicodynamics. Thank you for listening.